Hello and welcome to Selenium training series. This is the third session of our beginner series and I am Muhammad Abid Munif Khan. So before we start today's session, let's have a brief recap of what we covered in our session 1 and 2. So we started off with an introduction about the trainer and the beginner series. We will be briefly covering these two topics today as well. Next, we started off with looking at what is software test automation and its importance and answered some of the frequently asked questions about it. Next, we reviewed what is Selenium, its features and its components. Then, we started setting up our Java environment and the Eclipse IDE. After that, we reviewed what is Java as a programming language and reviewed the basic concepts of object-oriented programming. We also learned what is Maven and how we can benefit from it. And finally, we created a simple Java project as well as a Maven Java project having Selenium incorporated in it. We compiled these projects and ran a simple program where we opened the browser and a URL within it and then closed the browser. This was all done using Selenium's built-in functionality. So if you are new to software test automation and haven't reviewed the session 1 and 2 of this series, I would recommend you view those first, which will help you understand the bigger picture of software test automation and Selenium, as well as set up all the prerequisite steps which are needed to understand today's session. Now, before starting off today's contents, let's have a brief recap about the trainer as well as this beginner series. A more detailed version of these introductions is available in session 1. So if you want to know the bigger picture about what this series will cover, I would recommend you view those areas in the session 1. So starting off with the introduction about the trainer, so I started my career in 2004 as a software developer and then moved into the QA field in 2007. I've been involved in all kinds of QA activities like manual testing, automation, and process implementations. My special areas of interest include software testing and automation. From the automation perspective, I've created regression suites using tools like QTP, Test Complete, and Selenium. In Selenium, I've used languages Java as well as C# for my framework creations. Now, let's have a brief recap of what this series has to offer. So this is a beginner series in which we will learn the very basics of test automation using Selenium WebDriver. We will use Java as a programming language in this series, and we will learn all the topics which are necessary to get you started with test automation. During the course of these sessions, we will also cover a variety of Java topics so that your programming skills are also up to the mark, which will enable you to use Selenium WebDriver to automate your test cases. Following is the session-wise breakup of this 6-part series. We'll start off with the very introduction of test automation and Selenium, then we'll set up our Java environment and Selenium WebDriver. Next up, we'll explore a variety of topics related to Selenium, like exploring what WebDriver is and what are the object recognition mechanisms available in Selenium, what are weights, and lastly, what are page object and what is actually page object model. And as mentioned previously, we will also review some of the Java topics which are necessary to get you started with automation. So during the course of these sessions, we will cover the following Java topics. By covering these topics, we will enable you to have enough programming skills which will help you in your automation tasks. A more detailed discussion about the session-wise breakup and the topics which will be covered in each of the sessions, as well as the Java topics which will be covered during the course of these sessions, was done in session 1 of our series. So if you haven't already reviewed the session 1 of this series, I would recommend you view the introductory part of the session 1, which will give you the bigger picture of this series and what topics will be covered in this series. After a recap of these introductory topics, let's move to today's session. Today's session is all about understanding what is WebDriver. So the contents of today's training will mainly cover various aspects of WebDriver. We'll start off with looking at what is the WebDriver architecture, which will help us understand the bigger picture. Next, we will look at what is WebDriver interface and the driver executables. Lastly, we will have a look at what are the commonly used methods of WebDriver, and then we will use all of these methods in our practical session. Now let's have a look at what would be our learning objective of this session. So at the end of this session, we would have understood what is WebDriver architecture and what is the WebDriver interface and how to use it. We would know how the driver executables enable controlling of the browsers and how to set up these drivers and call them. We would know what are the most commonly methods of WebDriver, and we would have practical knowledge of calling these and implementing these within our code. Now let's start today's session. We'll start today's session by having a look at WebDriver architecture. As we had seen in our first session while introducing Selenium, that one of the biggest leap in the world of Selenium occurred with the introduction of WebDriver API, which drives the browser natively just like a user would. So before we proceed further, we should know some basic concepts of WebDriver, its architecture and how it works. In our last session, we wrote a basic program to open a browser, open a URL in it, and then close the browser. At a first glance, it might appear that Selenium is actually driving the browser directly from our code. But there's actually a little bit more going on there, and it's helpful to understand how our code did what it actually did by looking at the basic architecture of WebDriver. So here's the picture of the architecture for Selenium WebDriver, which is the current version of Selenium. So as you can see, it consists of three main areas. So now let's have a look at the WebDriver architecture in a bit more detail. So as we had seen that Selenium WebDriver architecture consists of three main parts, but it actually takes 5 components to actually accomplish the complete cycle. So let's review the three parts first. So these are the language level bindings, Selenium WebDriver API, and the browser drivers. The language level bindings are with which you can implement the Selenium WebDriver code. In simple words, these are the languages in which we are making our framework and interacting with the Selenium WebDriver and working on various browsers. The code using these bindings communicate with Selenium WebDriver API, which is the second component of this architecture. This API sends the commands taken from the language level bindings, interpret it, and send them to the respective driver or the browser driver. The third component are the browser drivers. So every browser has different logic of performing actions like loading a page, closing the browser, and so on and so forth. So browser drivers communicate with the respective browsers without revealing the internal logic of browser's functionality. The basic idea here is that each one of these drivers knows how to drive the browser that it corresponds to. So the Chrome driver knows how to handle the low-level details of Chrome browser and drive it to do things like clicking button, going to pages, getting data from the browser itself, and similar is the case with Firefox, Internet Explorer, and so on. So these drivers are internet browser specific, such as IE driver, Firefox driver, Chrome driver, and other drivers corresponding to the browsers. The remaining two components for completing the whole cycle are the driver servers or the driver executables. We will be looking at them in a bit more detail in our future slides. And lastly, there are the actual browsers. For understanding the execution of Selenium code, it's necessary to understand at least two of these components. The first of which is browser drivers and the second is the driver servers. So before moving further, let's delve into a bit more detail about how drivers are implemented so that you have an idea of what did the code we wrote earlier actually means. So just to refresh our memory, in our last session we executed our Selenium code which took control of the browser, opened it, navigated to a URL and then closed the browser. The code which we wrote was as shown in this picture. As you can see, we had created an instance of an entity WebDriver for controlling or taking control of our browser, which in this case was Internet Explorer or IE. You must have also noticed a new thing in this code. Unlike the process of creation of a normal object from classes as we had seen in our Java tutorial, we have not initiated this object of this entity by invoking a constructor of the same name as the entity. That is, we have not written WebDriver my browser is equal to new WebDriver. Instead, we have written WebDriver my browser is equal to new Internet Explorer driver. This is where we have actually called the browser drivers. But how have we done it? So let's have a look at this WebDriver entity and why does its object is initiated in a different way than the normal objects. So the WebDriver entity which we saw in the code is basically an interface. An interface is a programming construct within Java language and it is a collection of constants and abstract methods. Abstract methods are those methods which do not have implementation written within the interface. The implementation of these methods needs to be done in a class which implements that interface. So interface is like a contract that each of the classes which implements it must follow. So the WebDriver entity is actually an interface which serves as a contract that each browser specific implementation class must follow. Then classes for every browser were written which implemented this interface and are designed specifically for that browser. The following image shows the relationship of an interface and a class. So a class basically implements an interface. As I have mentioned previously that WebDriver is basically an interface. It does not contain the implementation details of the methods contained within it. Rather, separate classes have been written for each of the browsers and they contain the implementation details regarding that particular browser. So, the class which has been written or designed specifically for the IE browser is called the Internet Explorer driver. It includes the implementation of methods specified in the interface WebDriver, but only for IE browser. Same is the case for Chrome, that Chrome driver is the class which implements the methods from the interface specifically for Chrome browser, and so on and so forth. The classes for every browser which implement this interface are known as browser drivers. The following image will help you understand this scheme. Now coming to one of the points which I had mentioned when I showed you the code, that we had initiated a variable of the entity WebDriver in a rather different way in comparison to how we had initiated the variables of normal classes. So the reason behind it is that one thing to remember is that we can create a reference variable of an interface, but we cannot initiate any interface since it is just a contract to be implemented in a class. So WebDriver is equal to new WebDriver statement is not allowed. In the case of an interface, if we define a reference variable whose type is an interface, any object we assign to it must be an instance of a class that implements that interface. So now with all of this in mind, If we look at the code again, we will understand what we had written. In our example, that class is Internet Explorer driver and the interface is WebDriver. So we can say WebDriver driver is equal to new Internet Explorer driver. Same would be the case if we want to initiate the variables for Firefox driver or Chrome driver. So this the code which we had written, WebDriver my driver is equal to new Internet Explorer driver, should now be understandable to you that the WebDriver is an interface. We are creating a variable my browser for it, but it is initiated with the keyword new, but not the constructor or the class name again like WebDriver, but rather we should provide the implementation class, which in this case was Internet Explorer driver. Now that we know what is the meaning of the code which we had written, let's return back to the discussion of Selenium architecture and see its working and its remaining components. As we had seen that there are three major parts of the architecture, that is the language bindings, the Selenium API, and browser drivers. So once the command written in the form of the code are sent across the API and a reference of a WebDriver for a particular browser is created in the form of an instance of a class which implements that browser's behavior, like the Internet Explorer driver, now through it the commands are passed on to the actual browser. But for it to happen, it must communicate with the actual browser. As the browsers do not have a native implementation API in Java, so it was decided to do this communication via an HTTP server which implements WebDrivers via protocol. WebDriver protocol is a W3 standard that gives basic guidance on how a browser can expose itself for programmatic access. It also mandates a language independent interface so that browser can be controlled externally via any programming language of choice. In a nutshell, WebDriver implementation says that you can control a web browser by sending HTTP command requests. Each command can direct the browser to do something. These commands are issued by our test in the form of various WebDriver.actions like WebDriver.get, WebDriver.findElement, and so on and so forth. The browser driver sends these commands to the HTTP server, which determines the steps needed for implementation of these Selenium commands. The implementation steps are executed on the browser and execution status is sent back to the HTTP server, which sends the status back to our automation script. So to run a test on a particular browser, you must have its respective servers, which are called the driver servers, on your machine. Without the server running on your system, you won't be able to communicate with the browser. The Internet Explorer driver and the Chrome driver executables, which we had downloaded earlier and referenced in our code, are these driver servers. They are the HTTP servers which implement the WebDriver protocol for their respective browsers. So when our code runs, it first starts the server. Once the server is started, it listens on a port on our local machine, and when you run your tests, and it waits for the commands to come in, and when these commands come in, it interprets those commands and then automates the browser and then return those results back through the WebDriver API to the code, and you will be able to see the results. With all of this discussion, I'm pretty sure that you now understand the bigger picture of how Selenium is organized and how its code works. How various tiers of its architecture and different components interact with each other to actually execute the code and take control of the browser and simulate various actions on it. So you now will be able to understand this code in a much better way. Specifically, the first two lines in which we had first referenced a driver server, and then we had created an instance of a WebDriver interface and instantiated it with an implementation class. The next thing is that you can see we have used various methods like .get or .quit. So now let's look into the most commonly used methods within the WebDriver. So following are very commonly used methods within the WebDriver: .get, .close, .quit, .manage, .title, .getHandle or getHandles, and .switch2. So we will be having a look into these methods and how to implement them in our next practice session. Now let's get started in using these methods. Let's switch to our coding environment. In our previous session, we had already written some Selenium code to actually interact with the browser. So just as a recap, we had created a variable called myBrowser, which was an instance of an interface WebDriver, and then we had used few of its methods like the get method to actually navigate to a URL, which was Google in this case, and then we had used its close method to actually close the instance of the browser. So before we move forward, let's rerun it to refresh our memories. So it launched the browser, and then it navigated to Google and then closed down the browser instance. So as you can see, I'll just start off with going to the get method again, so as to show you that this is actually one of the methods which is on the which is available in the WebDriver, and you can see it accepts one parameter, which is a string, and this has to be the URL of the website or the web application where you want to navigate to. So previously we had used Google. Now we will use another one just for an example, and then we'll move forward. Okay, and let's rerun it. So now it went to w3schools.com, the exact URL which we had placed within the parenthesis for the get method. So now let's start using some of the other methods available within the within this interface. So let's start by using another method, which is to get the title of the window which was opened. So my browser dot get title. So here you can see that it is returning a data type of string. So it does not accept any parameters but returns a string to the main caller method. So let's use it here, and we need to then create a placeholder or a variable to actually store the title for it to be used later on in the program. So now it will get the title of the currently opened window and then will store it within this title variable, which is of string type. Now let's print it out again as well, just to see that it is correctly done its job. And now let's rerun the program. So get title is another method which is available within the WebDriver interface, and it has its implementation there. So let's rerun it. Window confirm method, it should be written here, so you can see that window confirm method. So this is get title, Again, we can use another one here, just current URL, which is of the same type, browser dot get current URL. Here as well you can see that it is returning a string to the caller function, so let's use it here, and that's why we had declared a variable of type string current URL, and again we can print it out to see that it has done its job or not. Let's run the program. Now you can see that the title had printed out this one, and the get current URL has printed out the whole URL. So these were pretty much simple and straightforward methods like get and then get title and get current URL. Now let's move to some of the other methods. Okay, so we had seen that our window was not opening as a full screen, but rather it was opening in a particular dimensions. If we want to make this browser as full screen, we can use another method which is available within within our interface or the instance we have created for it. And what we can do is here, so this time we will use the manage, and in the manage we have further implementation of what needs to be done. So if we click on the dot, you can see that we have a method for window, and within it, if we go and see, we have a method for maximize. Okay, so this way what would be done is that once the window is open by the get, and we have all of these things like title and get URL, it will get maximized and by this call, and then it will get closed. Okay, so let's rerun this program. So now it is open within particular dimensions. It now maximizes it and then closes down it. So that is another area, the manage method. Within it we have window, and then we can use its maximize to maximize the window. Next up, let's see another method which very closely resembles the close method. So if I go here and write down my browser, and then if I put a dot, you can see we have another method of quit. Now what is the difference between the close method and a quit method will become more evident if we have multiple windows opened or multiple tabs opened. So let's first comment this out, and to actually show you the difference between these two, let's move further and click on a particular element on the screen to actually open another window, and then we'll use first the close one and then the quit one to see the difference. So my browser dot find element. Now what is find element? We will be exploring find element and how to recognize the objects on the screen and interact with them in our next session. So I'm not going to go into details of what I'm writing here. It's just we are finding an element on the web page and then interacting with it. This is a vast topic and we will be covering it in detail in the next session. So what we will be doing is that on the web page which is opened, we will be finding out an element which will be a button, and whose class name is this, and then we'll be going to click it. So I'll just put a comment here that we do not need to worry about it. About this line, as we will be looking into its details in our next session. So once we will click on it, we will have another window open, and then we can see the actual difference between the close and the quit. Okay, now let's run the program again. So it has opened the site, and then it will click on the button, and you can see another child window was opened, and then the parent window closed down, not the child window. So this is the difference, that the close only closes that particular window on which its focus is. It does not interact with the child windows or other windows which are opened. Okay, and if we now enable the quit, you will see that the quit will actually close down the whole browser instance, and with that it will close down definitely all of the windows which are opened. Okay, so let's close this down manually and then rerun this program. Now it clicked on, and you can see now that both of the windows were closed down due to the fact that we had used the quit method. So this is the difference between these two. While reviewing the difference between these two, you must have also realized that when we had used the close method, it had closed the parent window and not the child window, because of the fact that the focus had remained on the parent window, and therefore it was closed. In our regular applications, when we are executing a test case and a pop-up opens or a pop-up window opens, normally the next test steps should interact with that pop-up window and not the parent window. So we were not able to do that using this code because of the fact that the focus was not shifted to the child window. So how do we achieve that? So we have few more methods which come into play and does change the focus from the parent window to the child window. So we have get handle or get handles. This is one set of methods. Another is the switch to method, which actually is used to switch to another window. So let's start using these two. So first of all, if we want to move from our parent window to a child window, we must first be able to uniquely identify both of these windows. The process of doing that is by using the window handle. So whenever a new window is created, a unique string is generated which is its unique identifier. So that string is known as a handle or a window handle. So the driver or the WebDriver has a method of get window handle, which definitely returns back one window handle for the window on which it is currently has the focus, while get window handles is another variation of the same method which actually returns back a set of all of the window handles of all of the windows which are currently opened. So let's start using these two, get window handle and get window handles, and then use the switch to method to switch the focus from the parent window to the child window. So now let's start writing the code for this. So at this point, when we had already opened and maximized the current window, the only window which is open is the parent window. So at this stage, what we can do is that we can declare a variable parent window and then use the method get window handle. So this way we can get the window handle of the opened window, which is only one at this point, and which will be our parent window once we have executed this step, and we have by this step we have opened the new child window. So before that we can store the string which is the window handle for the parent window. After that, once we have clicked on the button, now we will have two windows which will be opened, right? So now we can handles. I'll specify the data type after I have provided the method and seen its return type, which is a bit different from what we had already used in our previous sessions. So my browser dot get window handles. So you can see here the return type is a set of strings, right? So that's why we will use this, and once we have used this method, you can see it will definitely give an error, and we will use the same syntax which we had seen there as the return type of this particular method. Again, it will give an error because we haven't actually incorporated or included the Java library which has the definition for this. So if you see the error message, you can send it set cannot be resolved to a type, and if we just go here and use the options available to fix this issue, it is saying to import the set, which is a Java utility. So once we have included this, it will appear here in the as an import line, and now the error has also vanished. Now on this line, what we have done, after we had clicked on this button, we had opened a child window. So now there are two windows within our context, and now we are saying to the code to actually get the window handle for all of the available or all of the windows which are currently open, and then save them in the form of this variable, which is a definitely type of an array or set of of string types. So once we have this available, now what we can do is that we can write a for loop to actually loop through the windows and see if the window is not the parent window, then move to that particular window, which will definitely be the child window. So for this we can create another variable So what we are doing here, we have created a new variable window handles, which is again of the type string, and we are asking it to loop through whatever is available within the handles, and within the handles we have all of the window handles for the existing opened set of windows. And here we can write a condition if the window handle we have at the moment. Window handles, out of the window handles which are already available with us during this particular one iteration of this loop, is not equal to the parent window then here we will use the second command which I had talked about, which is the switch to. So my browser dot switch to and switch to what? Switch to a window. And you can see here the window method accepts one parameter which will be of the type string. And what will be that parameter? It will be the unique identifier of that particular window, which in our terminology we call as window handle, which we already have stored within different variables. So if I just go here windows and write the string as a parameter. Now the code logic which we are talking about is that pick up the window handles from the available window handles which we have got through this get window handles, loop through them and see if that window handle is not the parent window, then switch to that particular window which will be the child window. So here will be our this variable. Okay, so now we have completed this, and once we have moved to the child window through this line, we can now interact with it and do whatever we need to do. So for the time being, just to see that we have actually moved to the child window, I'll just place the same thing, because the child window will also not be the maximize at the very onset. So we'll just maximize it just to see that we were able to move to it, or we have switched the focus from the parent window to the child window. And then maybe we can just close that down so that we can also see that only the child window should get closed by this call, which will also prove the fact that the focus is on the child window. Next, we can just close the parent window, but for that to happen, we should also now switch back the focus from the child window to the parent window. And how we will be doing that? We will definitely be using the same statement here, but this time we will use the variable parent window, because we already have stored the parent window and we already know the identifier of the parent window. So let's use this, and now this line will switch the focus back to the parent window, and then when this method will get called, it will close down the parent window. So this is the usage of get window handle and get window handles, which will actually be used to get the unique identifier of each of the windows which is open, and then we can loop through them and then use the switch to mechanism to actually shift the focus from the parent window to the child window, or vice versa. So now let's just run this test case. So it has opened one window which will act as a parent window. Then it will click on the button, and now the child window is available. Now you can see the child window got maximized and then got closed, and finally the parent window also got closed. Now we have some other variations to this switch to method as well. So if I just go here and write it again, so you can see that if I just use switch to, after that if I just put a dot, so apart from the window which we had already used, if we again go here and see, we have frame. So if our application is using iframe, so after that window is opened and we want to interact with any of the element within a particular iframe within that window, we can now do it directly like we had done here by accessing any of the identification methods. We must first switch the focus within the frame, and again frames are identified by a unique ID, so that would be given in the form of a parameter, and this way our focus will switch from the window which is open to actually into the frame in which we have different elements where we want to interact with. Another method available is alert. So if we have alert boxes or warning boxes available and we want to click OK or cancel or get the text within that particular pop-up alert, so we can do that by using the alert method, and until and unless we switch to that alert, the focus will remain on the window and not on the alert box, and hence we will not be able to interact with those controls, be it the buttons of OK or cancel or any of the text available or written within the alert box. Now let's just write some code to actually use these two methods. So for that to happen, let's suppose a scenario in which the child window which we had opened has an iframe within it, and there are few controls within the iframe. For example, there's a button within the iframe, and when we click on the button, an alert box will open, and then we need to press OK or cancel onto that alert box. So let's first write down this scenario. So the child window has an iframe, and we need to just click on the button within the iframe, and an alert box will open, and we need to press an OK button on that alert box. So I'm just going to write some dummy code to illustrate this scenario and to actually tell you that how the code would look like. So let's start by switching to the frame. So at this point we have already switched to the child window, so we are already on the child window. Now we have to interact with an element within the frame, so we must first switch into the frame. As I had mentioned, the frame method takes a parameter which will be the unique identifier of that particular frame, and I'm going to just provide a dummy identifier here. So this must be replaced with the actual ID of that particular frame, which we can get by inspecting the DOM object using any of the inspector tools within the browser. So whatever ID is written there, we must replace that with this particular string so that it switches to the correct iframe. Once we have moved or switched to the iframe, we now need to actually interact with the button and click it. So the code would be something like this, which we had done previously, just that the identifier would be changed to the identifier of that particular button. So identifier. So once we have clicked on it, our scenario says that an alert box will open. So now we need to switch to the alert, which is open. And once we have moved to the alert, now we have the option to either click OK on it or click cancel on it. So for that, already built-in functions are available. So if I go here, you can see here accept and dismiss. So these methods will do the trick for you. If you need to click on the OK or the positive scenario or the positive command, we just need to use the accept, and if you need to use the cancel or any of the negatives of that particular alert box, you can use the dismiss. So I've written a dummy code just to illustrate the usage of these two variations of the switch to, which is the switch to a frame, and then from a frame or from a window if we need to switch to an alert, and then how to press OK or accept the alert or to cancel or dismiss it. And now coming to the last thing which will make this code actually functional is how to get these identifiers from the actual DOM object. So this will be the main topic of our next session, of how to identify elements on a page and how to get their identifiers. But just to give you a basic idea, I'll just show you some of it right now. So this is the actual child page, and within it we have this iframe available, and we want to click on this try it button. So if I just go and use any of the inspector tools like the F12, and if I just go here and try to click on the button, it will show me the HTML of this particular page, and within this page definitely there would be an iframe and this button as well. So if I just maximize it, you can see that this particular button lies within an iframe, and the whole page, the child page, starts from here with its head and body, but within it there is an iframe, and within an iframe there is again a head and body, and within it there is a button. So the identifier which I was talking about is, the first one is for the iframe. So you can see this is the iframe starting point and this is the ID. So we will be replacing this into the code. Okay, similarly we will be identifying the button and then we will be clicking it. So button is somewhere here. So this is the identification is the next session's main topic. So I was just giving you a brief idea of where to get these identifiers from the actual DOM object or the HTML of the particular page with which we are interacting. So this concludes this session. I would recommend that you use any of the applications which you are currently using to actually write the code to handle different child windows, switching between parent window and the child window, and if there are iframes or alert boxes available, interact with them. Use these switch to commands to either the frame or the alert to make yourself comfortable using this particular methods of the WebDriver and controlling different aspects of the browser. Now let's conclude this session by having a recap of what we have covered in this session and having a sneak peek into what lies ahead in this series. So moving to the recap, so in this session we have seen what WebDriver architecture is and what is the WebDriver interface. We have also seen what are the driver server executables and what is their functionality. We have now seen how to use the WebDriver to control our browsers and have used some of its commonly used methods as well within our script. Now coming to our next step. So till now we have had 3 sessions where we had the introduction of test automation and Selenium, and then setting up of Java and Selenium WebDriver, and then how to control the browser and interact with it using the WebDriver. Next up, in our next session, we will be reviewing how to find UI elements on the page and interact with them, and then controlling the test flow using delays or waits, and then lastly introducing the page object model. I hope you have learned how to use the browser and interact with it in this session. Thank you for watching this session. Happy learning, everyone.